divided by n counter is using a JK flip-flops as shown in figure. Assume initially A, B, C as zeros. Okay, he has given A, B and C. Okay, this is 3 JK flip-flops he has used. Initial conditions as 0. Okay, we have to find value of n. Now what is value of n here? Value of n in counter can be found. These initial states should be repeated again. That means we have to measure the count sequence. Okay, what is the divided by n counter? So we have to find value of n. Okay, now what is the truth table for JK flip-flop? Truth table for JK flip-flop is given as JK. Let us take this one as output Q of t plus 1. When these are 0, there is no change in the output. So Q of t plus 1 is equal to Q of t, or you can write this one as no change. Okay, when 0, 1, this is 0, 1, 0, 0. And what about 1, 1? This is Q of t bar, or you can say this is toggle condition in JK flip-flop. Now, how these are connected here? Initially, these values are 0, 0, 0. That means A, B, C values are 0, 0, 0. Now, if C is 0, what about the point at here? Q is equal to 0 since C is connected to Q. What about Q bar? Q bar is equal to 1. That means here we are getting input as 1 to the J for the first JK flip-flop, and K value is equal to Q. So this is equal to 0. Okay. Now, if you have 1 and 0 as the inputs to the JK flip-flop, now what is the output here? Output is equal to, this is not 0, okay, 1. Output is equal to 1 because JK flip-flop follows only J. Okay, when you have 0, 1, it is equal to 0, 1, 0 and equal to 1. So what is this value here? We have A value is equal to 1. Now what about the next state? Here in previous state we have A value as 0. Okay, similarly B and C. Now if you have Q value that is connected to Q, A is connected to Q which is as 0. What about Q bar? 1. If you have 0 and 1, what is the value of B? 0. Similarly, P value is equal to 0. So input to the J is 0. What about K? K is equal to Q bar which is equal to 1. So 0 and 1 output is 0. Okay, now again we have C is equal to 0. What about this one? This should be equal to Q bar which is equal to 0 bar 1. Again these values are J is equal to 1 and C is equal to 0. So K is equal to 0. If you have 1 and 0, again A value is equal to 1 from the truth table of JK flip-flop. Okay, now previous state we have A value as 1. So what about Q bar value here? Q bar value is equal to 0. That means we have input J as 1 whereas K as 0. So 1, 0 is equal to output is 1. So this is 1, 1. Okay, now what about the input at this point? Next state we have seen this as 0 and whereas this has 1. So input to the J is 0 whereas K is 1. So 0 and 1 output is equal to 0. Okay, 0, 0, 0 is given as 0, 1, 0, 0 is 4. What about this one? This state is 6. Now what is the next state? Okay, we have output C as again 0. That means which is connected to Q is 0 whereas Q bar is equal to 1. Now what about input to the JK flip-flop for the next state? JK flip-flop next state input is J is equal to Q bar which is equal to 1 whereas K is equal to Q which is equal to 0. So 1 and 0, JK flip-flop for 1 and 0 input we have always 1. So A value is again equal to 1. If A value is equal to 1 in the previous state, okay, what about this one? A is connected to Q which is equal to 1 which is equal to input to the JK flip-flop 2. Okay, so this is again we have here 1 and 0 which is equal to 1. Okay, now what is the last state of B? Last state of B we got it as 1. So J input is 1 whereas K input is equal to 0. So for 1 and 0 input to the JK flip-flop we have 1. So the next counting sequence is that is divided by n counter, it reads 7. Okay, now if C is equal to 1, that means output to the C is equal to 1 Now what about Q bar value which is here? This should be equal to 0. That means 0 should be the input of first JK flip-flop now. Okay, and K is equal to Q, which is equal to 1. Okay, now what is the value of A if you have inputs as 0 and 1? The value of A for 0 and 1 is 0 from the truth table. Okay, if A value is 0, now what about previous state of A? Previous state A value is equal to 1. Okay, previous state A value equal to 1. So 1 and 0 you will get it as 1 again. Similarly for C. Okay, now what is the next sequence? When C is equal to 1 again, first flip-flop JK values are 0 and 1. So this output will be 0. Okay, now previous state of A is equal to 0. Okay, now what about this one? Q bar is equal to 1. Now for 0 and 1 input to the JK, output value of B is, that is output value of Q is equal to 0. Okay, now similarly, what about this one? This is equal to 1. What about next sequence? It will be 0, 0, 0. That means here 3, we have 1 and 0. Okay, that means what is the sequence? What is the n value of n of this counter? 1, 2, 3, 4, 5, 6. So value of n is 6 since it counts only 6 clock pulses. Okay, now next question is, the output of the above counter is given to the circuit shown below, which consists of 3-line to 8-line decoder and LEDs is. Okay, we have to find here the LEDs that will never glow or. Okay, now if you see here from this counting sequence, after 0, okay, initial state 0, what is the counting sequence we have? 0, 4, 6, 7, 3, 1 and again 0 is repeating. Okay, only there are D2, diode 2 and, or you can say LED 2 and LED 5. Okay, so D2 and D5 they will never glow at all in this counter. So option C is the correct answer. D2 and D5. Since they are missing in this counting sequence, they will never glow.